Welcome back to the UAV Understanding Drones course. In our previous lecture, we learned about the components which are required to build the structure of the drones. Now in this lecture, we will learn about the components which control the operation of drone. Flight controller. The flight controller is the brain of the aircraft, capable of rotating the engines in the right way to achieve the desired movement by the ground controller or following the program guidelines in automatic flight. It is a circuit of variable complexity that has a series of inputs and outputs as well as a series of built-in sensors that determine in real time the position of the aircraft. The controller is in charge of processing both the information received by the sensors and the address data to send through a series of algorithms the appropriate commands to the motors using PWM signal for the correct flight. A microcontroller board can also be programmed to carry out the tasks performed by the controller. PICSOC. It is an open source autopilot system oriented towards inexpensive autonomous aircraft. It is a computer vision research based flight controller system designed by the Computer Vision and Geometry Lab of ETH Zurich and Autonomous Systems Lab. It consists of a PX4 Flight Management Unit, it is FMU, controller and a PX4 IO integrated on a single board with additional IO memory. GPS module. The GPS module measures your drone's location by measuring how long a signal takes to travel from a satellite and also gives an estimation of your drone's altitude. The main feature used by the GPS module is that you can autonomously fly your drone to waypoints, so your drone can potentially fly on its own from takeoff to landing. Since the GPS module needs to see the sky, it is often mounted on the top of your drone away from all the other electronics to ensure it gets a solid GPS signal. ESCs, Electronic Speed Controller. An ESC connects to the flight controller, motor and battery and aids in controlling the speed and direction of the motors. It is the interface between the control and power stage of brushless electric motors. It allows drone flight controllers to control and adjust the speed of the drone's electric motors by raising or lowering the voltage to the motor as required, thus changing the speed of the propeller. The electronic speed controller is also responsible for the direction of flight and variations in the brakes of the drone. When selecting an ESC, the following variables must be taken into account: maximum current you can handle, number of cells for which it is designed, that is the battery voltage, inclusion or not of BEC, form of programming from the transmitter by beeps or LEDs or by a passive card, existence of optocoupler, galvanic separation of the drivers from the transistor doors, and weight. Payload box. The payload box provides a space to store and secure the payload in the fuselage. It is recessed into the body of the aircraft through a hole cut in the bottom of the fuselage. Any product that has been shipped from one place to another place should be kept enclosed in this payload box. Payload boxes can be designed in any shape, but one should choose wisely the shape that produces a larger surface area to carry the deliverables. Payload boxes nowadays are used to deliver foods, first aid kits, and any such deliverables. Landing gear. Landing gear is basically the legs of the drones. In most cases, there are either 2 or 4 legs depending on the model. They are there to ensure the safety of your camera gear. Thus, they are only present in drones that serve the purpose of aerial photography platforms. Despite that, landing gears can also be found on some toy models, but they are either purely aesthetic or serve for protecting the bottom portion of the drone's PDB from water or dew damage. Drones that require high ground clearance during landing will require modified landing gear to allow them to land safely on the ground. The delivery drones that carry parcels or items may need to have spacious landing gear due to the space required to hold the items as it touches the ground. Landing gears also increase the safety of the drone. Transmitter. A drone radio transmitter is an electronic device that uses radio signals to transmit commands wirelessly via a set radio frequency over to the radio receiver, which is connected to the drone being remotely controlled. In other words, it's the device that translates the pilot's commands into the movement of the multirotor. A transmitter transmits commands via channels. Each channel is an individual action being sent to the drone. Roll moves your drone left or right in the air, literally rolling your drone. Pitch tilts your drone forward or backward. Yaw rotates your drone clockwise or counterclockwise, allowing you to make circles or patterns in the air. Throttle controls the amount of power sent to your drone, which makes the drone go faster or slower. Receiver. A radio receiver is a device capable of receiving commands from the radio transmitter, interpreting the signal via the flight controller, where those commands are converted into specific actions controlling the aircraft. It is important that the receiver and the transmitter are compatible with each other in terms of frequency and other parameters. So, these are all the basic and necessary components used for building drones. Now, the size, type, and configuration of these components vary with the purpose for which the drone is designed. If you are interested in building one such drone, then after getting all the components, improve the following skills. Firstly, improve your soldering skills if you are a beginner to ensure neat connections, higher reliability, and less resistance. Ensure correct polarity while soldering. Insulate the electrical connections with insulation tubes to prevent short circuits. Use heat to shrink the tube and hence insulate the components. Use hot glue for mounting components. Apply thread locking for connections that use bolts and nuts. This technique keeps connections together, but at the same time, components can be removed when needed. You can add LEDs to the drone to increase visibility at night. Use plastic, metal, or rubber materials for landing to avoid any damage to components, especially for drones with payloads. So, that would be all for now. I hope that you have understood the basic important components required when designing a drone. See you all in the next lecture.